All right, hello everyone, this is Mr. Crozier. I'm going to go quickly over review 3 and 4. We've done a lot of these in class. Number 1, simplify this down to tangent. Write what you're doing here. If you don't know the exact words, that's fine. Just write down what you did, like I switched cosines and tangents out. All of these are on the unit circle, so find them on the unit circle, do the computation. Number 3, evaluate here. Not on the unit circle, but if I use this identity, I can get it to unit circle pieces and do it. This identity right here looks an awful lot like one of these over here. Write it out. This becomes cosine of 570. This is on the unit circle. These two angles are the same right here, so you can just go ahead and do that one. Again, on these ones, very complicated. Draw out a picture of it. Draw the triangle in the right quadrant. Do the computation correctly. Again, where is this? It's right here. Solve the equation. Don't forget to multiply by 4/3 so you get it down to x and reduce. On the back, again, solve the equation. When you get to here, take this out, put this in, divide them both by cosine. When you divide by a cosine and a 2, it's 1 times sine, and multiply this back in here to check this. But this is a common mistake here. People don't know what to do right here. You factor out cosine. General solutions, times it by 3 and 3. Get common denominators, generate the solutions. Notice it stopped at pi, so I'm not going to go past 11/15. And it does go back 1 here. We didn't mark that in the answers, but it does go back 1 to pi over 15. Factor and solve. Sign doesn't go above 1. On this one, draw it, x2, and use this formula right here. You have a cosine formula that only requires sine. You don't need this right here. We could figure that out if we did need to do that. We didn't need to do that on here, right? If we needed to figure out this side right here, we'd say a squared plus b squared equals c squared, which is a squared is equal to 4 minus x squared. A is equal to root 4 minus x squared. If we needed that cosine value, that's what we would do, but we don't need it. Draw it, Pythagorean theorem, do the computation. And this one, this formula looks a lot like this one down here. All right, second page. On this one, this right here leads to this part of it, which is plus 2. So this is this, and this has 4 parts, which leads to negative cosine. Again, this comes up often. Factor out a cosine, solve the 2 parts. What does this look like? To me, it looks like one of these formulas down here. Tangent, draw the triangle, use the half angle formula. It's right there. There was a mistake on this one. We put a 3 there to make the problem work out. This is a huge one, right? Probably the number 1 identity on this page is right here. Make sure you know that one. Pops up on every test multiple times. Solve it, factor it, set it equal to 0, solve it. Straightforward, divide that. There's your angles. Don't forget to multiply by 3. On the back, straight factoring, solutions, sign doesn't go above 1. General solutions, get common denominators, start generating solutions. Well, again, we stopped at pi. You can stop wherever you want to. A lot of times it's 2 pi, this time it's pi right here. This is an interval, that's out. And if I were to go backwards and subtract 4, I'd be at a negative 1 pi over 6, which is not in the interval there. This one here, if this is my angle, again, a over 3. We're going to have to do this computation to get this. The tangent is opposite, which is a, over adjacent, which is this value here. Generally in math, if there's a radical number on the denominator, we usually fix that. A lot of times in math, if we have a radical with a variable, people won't mess with fixing that. Cosine down here, sine cosine product. Sine cosine product, whoops, this one, do that computation. There you have it. Draw this, do the computation, and draw this, and do that computation. On your test, this is the only thing you have to memorize. Everything else you can do your own way. Please memorize these steps. We take sine of 2 theta. It's theta plus theta. That's just addition, right? Theta plus theta is 2 theta. Then I use the sum identity. I run these thetas through this A and B and A and B. A and B are both theta. And then what I do is I flip these around right here. That's called the commutative property of multiplication here. Multiplication means, multiplication is commutative, right? 3 times 5 is the same as 5 times 3. So now look what I have. Sine cosine plus sine cosine. Well, that's just 2 sine cosines. Again, that's just addition. Memorize this step, all the steps here. This is identical to your test. This problem right here is on your test tomorrow, exactly like this. You'll be given this. You write down step 1, step 2, step 3, step 4, and you are done. Good luck.